The third area of forecasting the weather we are going to look at is precipitation. And what precipitation is, it's the rain, it's the snow and the hail that falls on an area. And a rain gauge is used to measure precipitation, okay? And the rain gauge is buried in the ground and it's away from buildings so that the water does not fall into it off the buildings. It's in a clear area. And the rain that enters the cylinder through the funnel. And the cylinder is marked in millimeters. So now we're looking at rainfall on the weather map. Generally, we always see rain on a weather map. It's always displayed in different shades of blue. So from looking at this map here, we can see that the lighter shade of blue means the less rainfall that area will experience. And then the darker and darker the shade gets, it means the more rainfall is going to hit that area. Another thing to note about precipitation is the clouds. Okay, so the clouds are groups of tiny water droplets or ice crystals that are held in the atmosphere. And we've got three types of clouds seen here. So we've got the cirrus clouds. They're high clouds that form above 8,000 metres and they're really thin and wispy. We generally see clouds like that in the summertime where we don't generally get a lot of rainfall. Then we have cumulus clouds and these form about 5,000 metres. And at the base of each cloud is flat and at the top of each cloud it's rounded, so these are the more puffy kind of clouds that we see. And lastly we have the stratus clouds and these are usually low clouds that form below 2,000 metres, and as you can see in the picture, they're large, they're thick, they're heavy looking grey clouds that fill the sky, and generally what is associated with these clouds is a lot of rainfall. Now what I'd like you to do in your workbook on page 78 is you're going to answer questions 7 and 8. Next we are going to look at the wind speed and direction. A wind vane is used to indicate the direction of the wind. So the wind vane itself, as seen in the picture, is a free moving arrow on a high mast, and we know that the arrow is on the left-hand side above E for east. The tail of the arrow is generally wide and blown forward by the wind, and this allows the head of the arrow to point in the direction from which the wind is blowing. Then we have the speed or strength of the wind is measured using an anemometer, and its units is kilometers per hour, so km/h. So we have three cups that rotate when the wind blows. So the stronger the wind, the faster these cups are going to move. And the number of times the cup rotates is used to calculate the wind speed. And this is recorded and displayed on the meter itself. Now we're going to look at the wind direction and speed on a weather map. So we can see that the wind is displayed as a white arrow. So it's pointing it here. We know that the wind is moving north. The number indicates the speed of which the wind in kilometers per hour. So we know that the wind is traveling at 20 kilometers per hour in a northern direction. And then lastly, over in the corner, we see the direction of the arrow shows the direction from which the wind is blowing from. Next, we are going to look at the Beaufort wind scale. Bit of history for you, but in 1810, an Irish-born admiral named Francis Beaufort invented a scale for measuring the force or the strength of wind by observing its effects on trees and water and other things like that. And to this day, weather forecasts still refer to the wind force as used in the Beaufort scale. So first one, we have light air and wind is 1 to 5 kilometers per hour, and we see the sea has scaly little ripples. Force 2, We've light breeze, and these are winds from 6 to 11 kilometers per hour, and we see the water is rippled into wavelets. Force 3 to 4, we have gentle to moderate breeze, and these are winds of 12 to 28 kilometers per hour, and flags can be blown about. Force 5, we've fresh breeze, winds of 29 to 38 kilometers per hour, with moderate waves and many whitecaps. Force 6, which are strong breeze winds of 39 to 49 kilometers per hour, and we've got large branches they can shake, and we can have difficulty with our umbrellas. Force 7, we've got moderate gale winds, 50 to 61 kilometers per hour, and the sea heaps up and we see white foam blown about. Force 8, we've gale winds, which are 62 to 74 kilometers per hour, and this makes it hard to walk against the wind. The sea has high waves and breaking crests and spray. Force 9, we've strong gale winds, which is 75 to 88 kilometers per hour, and this can cause slight damage to trees and buildings. Force 7, Force 10, we've got whole gale winds, 89 to 102 kilometers per hour, and this causes severe damage to trees and buildings. Storm winds, which are 103 to 107 kilometers per hour, so that's the maximum speed you can go down a motorway, and this has widespread damage. And Force 12, which has winds over 117 kilometers per hour, which will be classed as a hurricane. Next, we are going to look at humidity. And what humidity is, it is the amount of water vapor that's in the air. And a hygrometer is used to measure relative humidity, and it measures temperature and humidity. Inside it, a very thin piece of paper is attached to a coil, and when it absorbs air moisture, the paper then expands, which causes the coil to rotate, and which moves the humidity needle, and that's how we record it. A little fun fact, on a hot, humid day, it often feels hotter than it actually is. And that's because there's so much water vapor in the air that our own body sweat cannot evaporate to help cool us. So like myself and Monica from Friends, on a really bad humid day, my hair would tend to frizz an awful lot, and it's a nightmare. Lastly, we are going to look at sunshine. And a Campbell-Stokes recorder measures the hours of sunshine in a day. And how this works, so we see the solid glass ball, all right, and that ball concentrates the sun's rays onto a removable strip of card which is placed behind the ball. Now what the strip of card looks like is on the right hand side. The card itself is marked in hourly intervals, and as the sun shines through the ball, it scorches a mark on the paper, and that's how we forecast and record it. Now that we have gone through all the different types of ways we forecast the weather, what I'd like you to do now is you are going to pair up the pictures of the instruments with what the name of them is. So we have on the left hand side, we have the column of all the pictures of the instruments from A to G, and on the right hand side we have the names of the instruments from 1 to 7, and you're going to match them up. Next, you are going to create a mind map, which is all based around measuring and forecasting the weather. So we've gone through the sunshine, the atmospheric pressure, temperature, precipitation, humidity, the different types of cloud, wind direction, and wind speed. And I'm going to tell you the success criteria that you need to put in each of these sections. So in each section, you're going to name the instrument used to measure that particular type and or the method used. You're going to explain or put down the keywords of how the instrument works itself, what is the unit of the measurement, and how does the measurement appear on a chart. So instead of a synoptic chart, you're going to put in how it appears on a weather map. and put in all the keywords and terms that you've learned about each type of measurement. In summary, we know what the weather actually is, who studies it, who forecasts it, and so on. We look at the weather stations, so what do they do, how they gathered the data and how they analyse it. We've seen the weather maps and the different symbols and how the weather forecast is projected onto it. And we can look at interpreting the weather data. Next, using the information that I've given you, your books, and your mind maps, you're going to fill out this table here. So you're going to examine the weather instruments labelled A to G, and then you're going to fill in the grid at the bottom of the page. And some of the entries have already been placed there for you. So you're going to put in the first column the name of the instrument, then you're going to put down what it measures, and then the unit of measurement used where it's relevant. Or if you prefer to use this table here, there is one less, it's A to F, and again you're going to name the instrument, you're going to put in how it's measured, what it measures, and then the unit of measurement that instrument is measured by. And that's it for measuring and forecasting weather. I hope you learned a few things along the way.